Who thinks I don't have anything to do here? Please raise your hand. That's okay. I'll block this.
Can you check the microphone? Do you have the microphone?
There's a microphone, right? All right. Is it on?
Yeah.
Cool. So that's gonna be complicated because those kind of microphones go really, really bad with long beards. So you have to wear some weird stuff while I'm talking like this. I apologize. All right. So, creating offline IoT experience with beacons. Who has ever played with the beacons before? One can. Good, good. Who has no idea what a beacon is? Nice. That's good news because I have some slides about beacon. So that's who I am. My name is Laurent. As I said, I'm the counterpart of William Heng, who is a cache-based developer advocate based in New York. That submitted this talk about beacons. I'm based in Paris. You can find me on Twitter. You can send me an email. That's a tag cloud of stuff I like, but that's enough about me because we're already late. So what's a beacon? That's a lighthouse. A lighthouse emits a signal to anyone that wants to see that signal. It's just broadcasting to the world. It's not broadcasting something in particular like you would have with Wi-Fi, people sending it Wi-Fi, this kind of thing. It's just, hey, here's a signal, and do whatever you want with it. If you're on a boat, then that's great, because that's what you want. You want a signal to help you in the context of where you are, which is on the sea, to find where you're going, which is port. That's what a beacon is. The beacon we want to talk about today looks more like this. This is a small piece of hardware. There's different sizes of beacons. Those are common ones from Common Beacons Company. And what they all have in common is this thing that they run on Bluetooth LE. The full version of Bluetooth. It's low energy. With I guess with a key of that size, you can, that's probably that big. Battery can last up to 2-3 years because Beacon doesn't broadcast much information. It broadcasts the UID. It broadcasts 3 AD. The UID, like a 16-byte big, non-human readable UID, and 2 additional ID, major version, minor version. That's the iBeacon version. iBeacon is the Apple standard of beacon introduced by Apple when I was like, I don't know, 3 or 4 years ago, maybe more. I'm pretty new to that beacon stuff. Before William told me it existed, I had no idea what it was. So I'm a 2-week-old baby in terms of beacon. So I think it's 3, 4 years old. It's an Apple thing, but of course it's Bluetooth, right? So everything that works with Bluetooth, it works with it works. And as I said, there's a UID, 2 different versions in the minor version. There's 2 other stuff that you find in most beacon standards. There's a byte to tell you about the range of the beacon you want it to watch. From a range perspective, a beacon like this, Bluetooth LE is about 50 meters, and you can decide of that range. You can configure that range using that odd byte. So it's very much used for indoor stuff. Like GPS is something outdoors. While the GPS works, pretty much the same thing. It's broadcasting stuff. It's localizing something, but it's outdoors. There is no limit of range. Satellite. Wi-Fi has a broader limit of range. NFC has a very small range limit, probably at 10 centimeters. RFID is probably about 100 centimeters. It's quite small too. The best, from a size perspective, way of emitting something is Bluetooth, and it's low energy. It's much less consuming than Wi-Fi. So yes, they have a byte to tell you to configure the range of emission of a beacon. There's another byte that can be used to maybe tell you about the battery of the beacon. And then some other standards like Beacon or Edison Beacon. Beacon, Edison Beacon. Edison is the one on the bottom. It's a Google thing. It's new. It started a year ago, and it allows you to broadcast actually much more information. One of the interesting things with Beacon is telemetry. It's a good use case. You telemetry, you're basically broadcasting one stuff, which is a temperature, a battery level, just a small sensor that gives you one thing at one time. So that's what it is. It's a beacon. It's just emitting stuff, which is nice. But if you don't have an app that works with that beacon, then it's absolutely useless. So obviously you have to write an app that knows the UID of the beacon, the different version number of the beacon, and when it receives that signal, it can do stuff. So quickly, some use cases about beacon. There was a lot of people very excited in marketing and sales about enriching the user experience of people based on the context. What that means is, if you're on a store and you're walking around the store with your phone app and getting close to a beacon, and you might have a notification that says, hey, this thing on the right is on sale, it's 50% sales for people that have the app. Okay? So it lets you give notification, give something back to a user based on where he is, usually indoors. It can serve other purpose. If you tend to lose stuff, like a VGA Mac adapter, that happens, maybe you could add a beacon on this thing, and your phone will know what that beacon is. And when the beacon, which is your adapter, is to it, not in range anymore with your phone will say, you just lost your damn thingy. It's not on my range anymore. Where is it? That work with skiing, that work with other stuff, that work with a bike. You put that on a bike, go grab a beer, and then if your phone is saying your bike is moving, then someone is probably stealing your bike. Great use case, you're in a museum, and you have the app open, and you walk among the very cool thing in the museum, and each time you walk next to your beacon, the beacon tells you, okay, so that's what it is, that's who made this beautiful art thing, and that's why you did it. Information in context of where you are. Tracking sounds bad, but that could perfectly be used for tracking stuff in Amazon, big thing where they store stuff, places where they store things. They use RFID tag to actually locate things. You could also use beacons too. As I said, use stuff. Telemetry, scavenger hunts. When you go to conferences, they want you take the app of the conference, and they want to make sure that you go to every places you have to go to. So each time you approach a beacon with your app will say, oh, you've been here. So that's sort of a gamification thing. You're in FOSDEM. You're completely lost. My first time. Who is his first time at FOSDEM here? That's my first time. Okay. I got lost so many times already today. Beacon could help. If you have the venue map on the app and that can actually tell you based on where you are and what to do, that would be nice. Because I got lost. Anyway. Question is, what's Couchbase Developer Advocate doing here? Because I'm working for a NoSQL company, I work in database. I have no reason to be here. Well, we have this thing called Couchbase Mobile, and it's here to handle one problem, which is no bars. No problem, no bars has no reception on your phone. You're out of network. You don't have anything anymore. If you have an app that relies just on the internet, then your app doesn't work. There is a wonderful animation to explain that to you. You're connected to the cloud because you have network. That's great. You have a very poor reception. That's great. And from a user perspective, waiting. Everybody hates that. You don't have network anymore, and then your app doesn't work because requires to be online. So if your beacon app, when you find a beacon, requires you to do a call to the server and say, what am I supposed to do with that beacon? And you have no internet connection, and basically that beacon is useless. Because again, it's just emitting an ID. It says, hey, I'm a beacon, my name is that thing, I'm version 1.2. Please do something. But then if you don't have any internet connection, can't do something. So usually from a mobile app perspective, you end up having a very frustrated user because the app doesn't work because you have no network. It has to be online to work. And it's the same for several beacon apps. Your app has to be online to get the info that's supposed to show you based on the idea of the beacon. That's a very generic transition of cache-based model. People uninstall stuff because your app sucks, because it's freezing, crashing, or because it's slow. Usually slow can be associated with having no network. Sometimes it doesn't even work. The problem is data allocation. To make this work, you have to have local data and be able to sync the data when you have network, when you're online. So that's the idea, to make it, to have the best user experience possible. There's too many animation on those slides. And then you have a very happy user that gives you a great rating and that will keep on using your app, which is great. So again, what am I doing here? We have this thing called cache-based mobile. It's based off two things, cache-based Lite and a sync gateway. Cache-based Lite is an embedded database. So when you run this database in your app, on your phone, or on your Raspberry, or anything, if you're not connected to the internet, that's fine. You have a local database, you have the data. And then once you're connected to the internet, maybe you want to get an update on what the data is. Because Beacon, as I said, is just this thing that's going to stay for 2 or 3 years, depending on the battery life of the thing. And maybe you want to repurpose that beacon. Let's take that supermarket example again. You're walking down the alley and then there's a notification that says, oh, this product is on sale. Once this product is fully sold, you probably need to display another notification using the same beacon, because you're not going to replace every beacon this time you have to. It's very expensive. So you have to repurpose your beacon. In order to do that, if that data was on the local database, and you need to sync back to the server and get the new definition, the new message to display based on what's now on sale. That's what we have, the sync gateway, which is an app server, basically, that syncs the local database to the online big cache-based NoSQL server. That's what it does. That's how you do offline stuff with Beacon, basically. I could stop my talk here. I'm not gonna, because I have 10 minutes to do a demo and talk more about cache-based mobile. Cache-based Lite, 4 important things. It's document-based. When you store something in that local database, you just store a JSON file. And a JSON file, from a Java perspective, is just a map of string and object. This is extremely normal, basic stuff. There's no SQL or anything. You're just taking one object, JSON, and storing it in the database. Which is great, because now everybody's speaking about JSON. You know, all the HTTP API, REST API, they all speak JSON. You don't have any XML database because XML is dying. You have JSON stuff. If you have a database, usually what you want to do is query the content of the database. Cache-based Lite allow you to query the content of the JSON based on what we call an incremental map reduce function. Who knows what map reduce is, and should I explain map reduce quickly?
Those were 2 separate questions.
Yes, it was. I will explain anyway. A map function takes a document, like a JSON file, and allows you to do something with it, like add an entry to an index, which is exactly what we're doing here when we write an incremental map reduce function. Each time you add or modify or delete a document in the database, we will run the map function on that thing, that document, and if doc.types equals beacon visit, then emit entry in index whatever. You've created an index, which is basically a 2-column table. There's a key, there's a value, and you can query that. That's how you query the content of the JSON file with cache-based Lite. 2 other important things. That lightning thing is here to tell you that this is all event-driven. In the sense that you don't have to, it's fully synchronous. You don't have to tell the server, hey, give me the update, wait for the update to happen, then have the update, then do the query again. There's a listener model, basically. So you can listen to document changes and do stuff while they change. It's important to have this model because when you go offline and online again, there's one thing that can happen, that happens often. You have some synchronization issue. I've updated the document while offline. Someone updated it already and sync the updated version on the server. There's a newer version online than the one I have on my phone and that I updated. So I have a conflict, and the good thing is with a listener model like this, you can listen to conflicts, and when you have a conflict, you can decide what to do with the conflict. Am I going to overwrite everything? Am I going to do a merge based on the content of my document? There is no way to do automatic conflict merge because that's very tied to your business model. So there's really nothing you can do from an automatic perspective. So with the listener, we give you the ability to decide how to merge these conflicting documents. And then the other part with the reload sign is the sync gateway. You can sync the content of your local database to the server side of things, which is basically saying when you're online, you can update your database because when you're offline, you still want everything to work. Which is why I'm here, because offline is important because you don't have network all the time. Let's say you're at a music festival, there's beacon everywhere to basically track where people are going. When you're at a music festival, try using your phone and call your friends. Everybody's doing this, so the network doesn't work. There's no internet. It's fact. In IT conferences, it works better. I'm actually surprised that the Wi-Fi here works pretty well. But when it doesn't work, you still want to know where people go. So when you're walking around with your phone and the app as a service in the background that's basically storing every time you go next to a beacon, we can store that offline. And then when you go back online one day because you finally got the internet back because you got back home from the festival, then you can send all your information to the database, the festival people, and now they can say, oh, there was way too many waits in this area, or we should probably make that thing bigger or whatever. Quick sample of code, iOS version, Android version. As I said, a JSON file is just a map or a dictionary. There's a key, there's a field, very simple. I have 5 minutes to talk about a sync gateway, which I'm not going to do. I'm going to use those 5 minutes to hopefully do a working demo, which is always this weird thing to say, working demo. How do you test those beacon things? There's many ways to do that. Basically, what you require is a Bluetooth thing. I have a Raspberry Pi with a Bluetooth key, and I was supposed to plug this somewhere is my battery that I have here, so I'm not going to do it anyway. But I have another Bluetooth key here. So I'm running this image called Virtual Beacon, which is just a Debian instance that allow you to transmit stuff like, hey, I'm a beacon, get my data. So I run out beacon transmit. Hopefully this will work, which now don't, and it's frozen, but that's okay. I will run my Android virtual machine, which hopefully also has, that's my small micro USB Bluetooth key. So it's gonna run. Okay. Let me make sure that my sync gateway is running. It is running. That's good news. And it just picked up my beacon. That's a Debian Hello VM beacon. Which is good. What I want to do now is pretend that the beacon purpose has changed. So I'm going to repurpose my beacon by updating my document, which is a JSON document, which is working. Don't do demos that totally never work. What's wrong? So the goal of that demo was to restart the server. I'm assuming I have network issues.
But it's a local on your machine.
Yes, it is. be on the same network as everyone. It bridge on the network and it should work. Should. Do I have internet? I don't. Sucks, because that means I cannot go with my bridge of my virtual machine to my computer, which is why it's not working, which is extremely sad.
Can you try the FOSDEM fallback?
FOSDEM fallback? Maybe. I need something really need something really that should be much better. I hope it's because I have two demos today, one that require a NAT configuration with my VM and the other bridge configuration with my VM, and I was bridged, and hopefully that's the reason why this is not working. Hopefully. Yes. Alright, so what was supposed to happen is, I was supposed to go on the SYN gateway, documents, yay, no. Take my user, the other user, look at that document that said Debian hello VM beacon and let's say for them, whatever. Save the document, so I'm repurposing my beacon, go back to my app, launch the damn thing, and see that it's not saying, it's now saying FOSDEM something somewhere, which is not. Well, that was what was going to happen, and it's not happening for some reason. I don't know why. Unfortunately, I cannot show you code, but as I said, the code is pretty straightforward. You have database objects, you have a map, you store the map in the database, done. And then you have this thing called a push replication or a pull replication, which is to say I'm pushing data to the server or pulling data to the server. What's supposed to happen here is I'm pulling data through the SYN gateway to the local database to repurpose my beacon. And that doesn't work because I have networking issue. And I'm sad, and I should have done a video. As I said, I need that beacon thing. So that's it. Thank you very much for your days. I'm going to do a tutorial. Waffles! Waffles! 3 waffles! That's 3 waffles for you, sponsor by Cafe.
We have 5 minutes of break. We're going to leave the room now.
Yeah.
So if there are 3 seats in the middle, please move together so that people can come in. Okay, I'd like to introduce Diamit.
So my name is Diomit, and I'm a software engineer at Sazanta. We can give you a brief overview. We are a startup.
So it's not amplified. It's recording. And if you have a question from the crowd, please give me the microphone so that it's going to be well recorded on the video.
So we are a recent startup. Some of you may know Mongoose Web Server. We are founded. The startup founded by Mongoose Web Server, and decided to go into IoT to broaden our products to provide a full stack IoT platform based on JavaScript. And with the goal of, we learned from experience with Mongoose that people want more than just embedded HTTP server, and we aim to provide that. So in particular, we are aiming at the army of web devs. We want to bring them onto embedded programming, embedded development. For this, we found that the market lacked a JavaScript engine, so we are writing one, and there is separate talk about that tomorrow, which I encourage you to attend if you're interested in that. We emphasize we are targeting ECMAScript 5 compatibility, and our emphasis is on small footprint, like kilobytes footprint. But this talk is not about that. The event we talk about that is tomorrow. The platform, we aim to provide a complete solution with device firmware and cloud part and a communication protocol between them. But which you are not obliged to use. You could use whatever you want on the device. You could use all of that, or each of those parts is intended to be separately useful. So the device part is open source under GPL. And we are targeting multiple platforms, and we started with ESP8266 and the CC3200. We also have a POSIX port which will work on your Raspberry Pi. And today I'm going to talk about our experience porting on these two platforms, these two embedded platforms. Because the reason the reason is when I look back, these platforms are as different as you can imagine, and pretty much in all respects. And I would like to highlight those differences and how we tackle them. So I'll give you an overview. Some of you may know, for those who don't, CC3200 is a system on a chip with Wi-Fi capability from Texas Instruments, which is a major vendor. This is their IoT play. They very much, there is like all the resources, like resources of a big corporation are behind us, and this is their push into IoT. They use a well-known ARM, a well-known processor. It's an ARM Cortex-M4 core with an interesting architecture, which shows that it's having everything on one chip, which means a radio and application processor, is not common. Usually it's like you have an RF chip and you have your application chip, and this one integrates them on the same die. But they are still kind of separate because you have two separate cores. One is called network processor. It's a CC3100 network processor and application processor on the side. They are connected internally by SPI, but otherwise you do not actually get to program the network processor. It's a black box which you talk to over SPI. It has a fairly beefy 256K of RAM. It doesn't have any built-in flash. It uses external SPI chip. So yeah, it uses Wi-Fi. It actually has pretty much all the features you expect from this, from a chip like this. I2C SPI interfaces, two serial UARTs, pulse width modulation, timers, hardware accelerated crypto, RTC, 4 analog converters. So all the peripherals, all the usual peripherals are there. The SDK, whatever I say next, I'm going to commend TI on their SDK because it's really, really good. It's well documented. It's actually, all of the SDK is completely, apart from their proprietary TI RTOS, which I don't know why would you use. They ship complete sources for free RTOS, all rebuild configuration, so you can rebuild. They ship binary blocks for sure, but you can rebuild all the contents from sources, which like very commendable. And we use that to reduce footprint somewhat. So that's all good. Hardware, I mean, data sheets. You know, what else can you ask? When I was implementing I2C driver, I actually could go and read everything about how to drive the module, the internal I2C module. Like this was after my ESP experience. So this was like ironic. Anyway, so the price though is to build. So what you buy is you can buy a chip itself, and but what you usually buy is a module that you plug on your PCB. This one doesn't have integrated antenna, so you actually have to trace the antenna as well, which is a bit of a pain. But basically, it's $25 on DigiKey and about half that, like kind of non-official alternative module on AliExpress. So that's kind of the industry standard. However, this is the newcomer. This is the interesting thing. They are kind of an accidental IoT success by a small Chinese vendor. I will show you how they started. This is from what they started. So it's kind of obvious when you look into this that they didn't intend to become an IoT vendor, but they did. So it's a fully custom design. The silicon is fully custom designed by the company's CEO, who did a really good job. Like the hardware is top notch. It uses like a modular for the CPU part. So RF is all custom designed because this company CEO is in the past an RF designer. So, but the CPU parts are kind of from the building blocks of a thing called Extensa. It's an 80/160 megahertz. You can overclock to 120 megahertz. It has a 96K of data RAM, instruction RAM. It also doesn't have any built-in flash. It is SPI only, but with a very, very useful feature that it does have a rudimentary MMU. by which you can translate directly, address space is directly translated onto SPI with obvious performance impact, but with some 32K cache behind it, so it's not terrible. It's in practice, it's fine. Being a relatively obscure instruction set, the open source, of course, the company behind Extensa, they sell proprietary compilers, but we are not interested in that here, right? GCC toolchain is up until very recently was like a one-man effort by an employee of the company, but still, it's just one person. And GDB support is still kind of shaky. One interesting thing it supports is it can run AP and the station at the same time, which is kind of useful on different channels also. So it doesn't have as rich set of peripherals because, as I said, I don't think it was intended as a general purpose. What it was intended really is to provide like a Wi-Fi shield for your IoT projects. It's curiously nice. It does have I2S, but it doesn't have I2C. Internally, it has SPI. It has 1.5 yards because one of them you cannot really use because it's multiplexed to pins that are used for SPI flash. Well, you can only use TX, but not RX. It's kind of weird. It has one ADC that is 0 to 1 volt range, not very useful. So you have to have an external divider. Now, the software side of it is completely, as I said, like it's complete opposite of TI in quality because plainly it sucks. There are two SDKs and both of them suck. One sucks more, the other sucks relatively less. Given the origins, I think it's explainable because, as I said, it didn't intend to become. And I'll go into a bit more detail about that. There is absolutely zero data sheets. Like data sheets are unknown in this space. All you get, the best you can get is headers and then kind of guess, and then some examples. So you can kind of deduce what hardware does, but zero data sheets. None. That's just not unknown. However, what's interesting about that is that the module, as I said, is that you plug into your project to get the Wi-Fi connectivity, and it includes antenna on the module as well. Is under $2 on AliExpress. So that gets people interested. And so this is the ESP01. This is the very first device where this is what became popular. As you see, there is an SPI flash chip and the processor itself. As you can see, there are only, like this is the Wi-Fi chip. It has RX, TX, it has the supply voltage and the programming pin. That's it. It's not intended to be connected by peripherals. However, people got interested. They reverse engineered it, and the company actually picked up on it and went into IoT space, decided to release SDK. Their first efforts were really miserable. But what you get with this is really not enough. So you get 2 GPIOs, and if you want more, people were doing this. So this is what you do for GPIOs. But yeah, there was enough interest that this was actually good enough. However, we are past that. So this is the latest module that gives you all the breaks out all the pins that you can really get from this. And they have subsequently got the FCC certification and CE certification, so it's all kosher now. So this is what you can buy for under $2. Now, so what I'm going to tell you, so the origin, yeah, it's as opposed to explicit IoT push by TI. This started with a module that got reverse engineered by the community, and it's just interesting that the company, so they didn't fight it. They decided, maybe there is something in this IoT thing. So they started releasing SDKs, but they weren't very good. Like, I mean, they just don't know what function declaration is. Like, I mean, it's obviously, they just don't declare the functions. Like, they don't need it. They just ignore the warnings that you have, that you use.
WIO.
What?
When you do WO, you get all the warnings.
You get warnings like it's terrible, but you don't do that and it's all fine, right? So you just use a function, you know it's there.
Ignorance is a bliss.
Yeah. So exactly. But
it's been going from version to version. They use a function and they just don't declare it. The thing does not compile with with all warnings, so you have to declare that yourself.
Have you tried submitting patches to them, by the way?
They are not very they don't have open source well, they're not very receptive to patches, I shall say. Anyway, so they use the whole SDK is a bunch of binary blobs, but it is based on things like XTLS, LWIP, which they don't ship headers for. Instead, for example, for networking, they built something that's called ESP connection library, whatever, which is another layer on top of LWIP, because LWIP is not good enough, I guess, with these two APIs. I don't know why. Anyway, this thing just sucks. You just shouldn't use it. So we finally, one thing we persuaded them to do is to just release the headers for the LWIP.
Yay!
So now you can completely bypass this thing and just use LWIP, and it all works. The state of WTF is really amazing. Like this, as I said, the documentation for this is spread all over the forums, different code repositories with examples, reverse engineered ROM. I mean, it's just. However, as I said, the community has been very excited by I guess, the price point, and it's actually the hardware is really neat. I'm commending them on the TI is somewhat strange on hardware. The ESP is it's beautifully designed hardware. I wish it was documented better. Let me go to CC3200 so I can tell you. Right. So right from the beginning with CC3200, what we ran into is that you cannot flash the thing without some stupid Windows tool. Like this is, I mean, so we took. There is actually an open development platform called Energia, which is a fork of Arduino, and they ship like kind of half-assed flashing tool, which lets you just flash one file and that's it. So we weren't quite happy with that, although we did use it for in the beginning. So we reverse engineered the protocol and we integrated. We shipped implementation in our own flashing tool. So at least that's all. But it's kind of like why would it? There isn't even a Mac version. Okay, and we are used to not having Linux versions, but not even a Mac version. What the hell, really? Now the fail-fast story is quite interesting. So the flash on CC3200 is it's not a flat address space with blobs. It's actually a file system. But the problem with this file system is it's really you cannot do much. So you have to. I mean, it's so first of all, you cannot access the flash other than through this file system. This is a problem. If you want to, for example, store things that you don't know the size of in advance, and on this file system you create a file and you declare the size in advance. Also, you can only open files for writing with truncation, so it's like there is no append, there is no open for read and write. No, just open for writing. It's truncates. So that was really, and with SmartJS in particular, we provide a file API. So for this, and there are strange other strange things. For example, when you open the file for writing, it does look like because it's on flash, so there are certain semantics that you can only reset bits and not set them. It will let you do random writes, thankfully, but it will have this weird semantics that you can only reset bits. So it's not really writing; it's resetting bits. But never mind that. So what we instead did, it's basically it's very weird. And with SmartJS, our primary goal is to to smoothen the bumps, you know. So we provide what looks like a POSIX file API, and to do that, we actually implemented SPIFs, which is a SPI flash file system, inside the container files on this failfs. Yeah, that was we have a blog post about that. But basically, they acknowledge the problems with the file system, but they say they will not fix it because this product is now they don't add features, and apparently. Opening file without truncation is a feature. Right. Well, they are active on the forum, by the way. They do interact. Both of them actually have forums. Both of them interact, and TI is actually quite responsive. The problem is the responses are often okay. It's okay. Wait for next silicon. It's not good enough. And the biggest problem with TI is that the RAM. 256K seems like a lot, but the problem is that it doesn't have an internal flash, so it loads all the code into RAM. So your code and data and RAM is shared. So 256K is all you get, which is really not good enough for our purposes because our firmware is quite fat. We have to fit all the JavaScript interpreter, the libraries, the things, and still have some memory left for application use. But there is really no way around it. It's just 200. So what it does is the bootloader loads the firmware image, lets it run, and then, well, you can. It's basically there is no memory. There is no memory mapping of any sort. There is no memory protection so you could implement some. It's basically it's a dead end. We reached a dead end that we ran out of code space, and now we cannot add features to Smart.js because of this. Or it's either so we would have to go to something like DOS overlay days to implement something like that, but we just don't want to do it. So that kind of sucks. It's like it's a big problem for us. The problem is that Cortex A4 core lacks any kind of memory management unit. They didn't think about implementing it. Usually the controllers have embedded flash that just sits on the system bus, so it's like direct mapped, it's all good. But here it's SPI, it doesn't have any direct mapping as the kind of that ESP does. And yeah, it's really a big disadvantage in that way. And I actually went through everything pretty quickly. Let me see. I have 5 more minutes. So yeah, that's the upshot is that we managed to, in the end, we managed to a certain extent that you don't see all this terrible tragedy of ESP SDK, or like you get the same JavaScript environment on both platforms, and we suffered so you don't have to. This is a graph of popularity, though, so you see why it makes so see the both platforms started, even the CC200 got a bit of a head start on ESP, but you can see the interest, relative interests in both platforms, this is I mean the suffering through all the idiosyncrasies was worth it because there is incredible community around the ESP. So what's next? The ESP32 is the next chip from Espressif Systems. They learned from their mistakes, and they are adding Bluetooth, so it will be Wi-Fi and Bluetooth. They're adding more, so the chip has more pins. There is more GPIOs. They are added I2C and hardware PWM. They have second core. Yeah, there is a. Oh, I didn't mention. Yeah, second core. Yeah, there is a second core, so we were first when we heard that they were adding a second core. We said, oh great, now we have this SDK and all the SMP issues. That. I mean, these people. I mean, the people don't know about function declaration. Like, what do they know about locking? I wonder. So no, but fortunately, it looks like first it will be able to. It will be possible to turn it off, run it as an independent core with a shared memory region, or run it in SMP configuration. Like that. Please don't. Yeah, so it has more RAM to begin with. It has the same SPI, transparent SPI mapping of memory regions to SPI, and it looks like the memory regions will be even more flexible in the configuration, so we will be able to change the division between the amount of IRAM you have and DRAM, and how much goes to one core to the second core. The silicon is in beta. We actually do have beta silicon, and we are starting to play with it. So we plan to be, the release date is in a couple months. So we plan to have full support by the time it goes general availability. Smart.js should be there. Maybe not supporting, because some of for example, Bluetooth is currently completely undocumented and unsupported in the beta SDK, so we cannot even start on that. But as much as we can, we will have by the day of the release. And it's yeah, it's quite interesting. The SDK, I'm happy to say, the SDK on ESP32 looks like more mature. At least they started. Looks like maybe they hired some new people that actually understand more, and it's looking much better. So yeah, that's the future looks bright with ESP32.
You have 2 minutes left for questions.
Yeah. Do you have any questions?
Do you have any idea of the price point of the ESP32? Do you have any idea of the price point?
Yeah, price point. Well, I don't imagine, like, they understand that their biggest advantage is that under $2, because otherwise people wouldn't put up with all the hassle. So I don't, but I don't expect it to be much more expensive.
We had one here just to show you what it's like, just by coincidence.
Is it the 32?
Yeah, it's 32.
Well, no, this is the 8266. This is the 12E module.
It's the old one.
The one I have, yeah. Any questions? Any other questions?
I had a question about the SPI. You said so. Actually, on the ESP, there is one flash chip.
Yeah.
The new on the ESP01 was like 512K.
Yeah.
On the new one, it's 4 megabyte.
Yeah.
On the TI, you said you had a difference between SPI mapping. That on one for the ESP was.
There is no SPI. The SPI mapping I refer to is basically when your read and address in certain region gets transparently mapped into SPI region of an SPI flash in ESP, which is quite handy. We do OTA updates that way, so we keep 2 separate images. On TI, there is nothing like that. I think they ships with a variety of modules. But see, the problem with for us, at least for us, on TI, the flash capacity is irrelevant because only part of that can be used for code. I mean, you can write data. I think the ships with 8 megabits, 1 megabyte flash. The code space is really the constraint for us on TI.
I was wondering what's the actual limit for the amount of flash attached to an ESP66, because now we have flash chips with 16 megabyte or 64 megabyte. So
There is
I don't know if you have ever dig that problem.
There is a limit, I think, on the size of the code window you can map. And if I'm not, I didn't work with that in particular, but I heard that I think it's 8 megabits, so it's a 1 megabyte window. But you can access flash via SPI for data. You can access flash beyond that. So there's no problem. Although I personally have not seen and have not attached flash more than 4 megabytes.
Gentlemen, thank you very much. Let's finish there.